What are radians? By now you should be comfortable with degrees, and you should know all of the degrees from 0 to 360 and those angles. Radians is like the same thing but different. It's like speaking a different language, all right? If it's like we're going to be able to translate between degrees and radians and go back and forth. And even though you're comfortable with degrees, you really don't want to use that language right now. So what are radians? Okay. Well, what's an American? An American is someone who's from America, and a Mexican is someone who's from Mexico, right? Well, a radian is something that's from a radius. So we're really talking about a radius, and we're talking about an angle related to a radius. So 1 radian, if you could mark off on the circle a distance that's exactly equal to the radius, okay? Look at that angle that intercepts the arc that's equal to the radius. That's 1 radian. That angle is 1 radian. So here's 2 radians. I would just take that distance, that radius distance, and travel around the circle 2 radiuses, or 2 radians. There's 3 radians. Look at that angle. An angle of 4 radians, 5 radians, 6 radians. You can see 6 radians almost goes all the way around 360 degrees. Oops, we're not allowed to say 360 degrees. We have to talk in radians. Okay? In radians, you're going to be in terms of pi. All right? So we can see 0 and pi over 2 and pi and 3 pi over 2 and 2 pi is all the way around. So we wouldn't say 360 degrees. We'd say 2 pi. If you go halfway around is called pi. And we know pi is about 3.14, so it should make sense that 3 radians is almost halfway around. 3 radians is almost to 3.14. When we say 3.14, we're talking about 3.14 radians. And we know 2 pi is about 6.28, so 6 radians is almost all the way around. If you look at the top, and you think about 90 degrees, you're comfortable with a 90-degree angle up at the top, but we would call that pi over 2 radians. Pi over 2 radians is about 1.57, and so you can see that 1 radian is not quite to 1.57. Down at the bottom, that's 3 pi over 2, and that's approximately equal to 4.71 radians. So 4 radians doesn't quite make it to 4.71. You're going to be tempted to revert back to degrees because it's comfortable and you're good at 30 degrees or 150 degrees or 180 or 360 or whatever, but don't be tempted to go back to degrees. You really don't want to. Once you learn radians, it's probably going to be faster and easier. So let's look at an example. If I had to draw 2 pi over 3 radians, all right, 2 pi over 3 radians, really what you're concerned with has to do with fractions. So watch what I'm going to do. I'm going to change the pi and the 2 pi to get a common denominator with the 2 pi over 3. So all I did was I'm thinking of pi and 2 pi in terms of over 3. So I know that pi is 3 pi over 3 and 2 pi is 6 pi over 3. I haven't really changed anything. I'm just looking at a common denominator. So we want to march around the circle and think about that fraction, okay? That would be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. So we're just cutting the circle into parts. And if you look at the angle that corresponds with 2 pi over 3, there it is. That's the angle. That's 2 pi over 3. Now remember, back to last chapter when we talked about a reference angle was how far we are off of the x-axis. And so we're going to be concerned with that reference angle. The reference angle is going to be pi over 3 because we're 1 pi over 3 away from that x-axis. And that's going to be important because we're going to look at the same chart that we've been looking at. All right, we're going to look at pi over 3 in that chart. It's going to be very tempting for you to say 60 degrees, but don't do it. You don't want to say 60 degrees. You want to say pi over 3. So let's look at a different example, 7 pi over 4. So the first thing that I would do is I would think about pi and 2 pi in terms of common denominator 4. So all I'm doing is getting a common denominator so that I can make that comparison. So mark it off. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. If you do it that way, then it should be easy for you to see where 7 pi over 4 takes us. 7 pi over 4 is right before you get all the way around to 8 pi over 4. There would be a reference angle of just 1 pi over 4 or pi over 4. That's going to be important as we look at our chart, because we're only going to have to look at the column for pi over 4. (6.2) The unit circle and circular functions. So we already know the 6 trig ratios. All right, we know sine is y over r and cosine is x over r. We already know those, so get those down. But when we're talking about the unit circle is a circle with radius 1. And so if the radius is 1, then that means sine is just y for the unit circle. And cosine is just x. Okay? And so then cosecant, if the radius is 1 in the unit circle, would be 1 over y. And secant would be 1 over x. So it kind of simplifies our fractions a little bit. And this is only when we're talking about the unit circle, a circle having radius of 1. Here is the unit circle all filled out. Okay, now there's a lot of information here. If you want to take a picture of this so you can use it later, that would be a good idea. But this has all the information that you would need. Okay, the unit circle is awesome. Imagine if I gave you the problem sine 5 pi over 4. Okay, if I said sine 5 pi over 4, here's what you would do. If you have the unit circle, you would find 5 pi over 4, and since you know sine is y, you would look at the y coordinate, and you could see that the answer here is negative square root of 2 over 2. Okay? Now, I prefer the chart, and we can do the same thing with the chart, but the problem with the chart is you have to think a little bit about where it is. So if I was going to do the same problem with the chart, I would know that this is a pi over 4 reference angle, and so I would have square root of 2 over 2, but then you have to think about where 5 pi over 4 puts us. And since it puts us in the third quadrant, you have to say, oh yeah, well sine's negative, and that's how you get that negative result. Okay? So some people will say, well, why would I want to use the chart? Why wouldn't I use the circle every time? And the answer is, you're not going to have the circle in front of you all the time. The circle is great. It's got all of the information in front of you. If you have the circle in front of you, then use it by all means, but I'm saying you're not going to always have the circle in front of you. So that's when the chart is more useful. Okay? The chart is going to be more useful because it's a lot quicker to come up with the chart. So you should be, if I were you, I'd be able to use both of them. Okay? Let's do one more practice problem. If I did tangent, let's do tangent 11 pi over 6. So if you're looking at the chart, you'd say, okay, well 11 pi over 6 is right here, and you would have to remember that tangent is y over x. That's your ratio, right? That's your fraction. Okay? And so if you do y over x, you're going to have negative 1/2 over square root of 3 over 2, and the 2's cancel, and you're going to get negative 1 over square root of 3. And you'd have to rationalize that. I'm out of room, but you'd have to rationalize that. If you're using the chart, you can still do the same thing, but you've got to think about it a little bit more. You'd say, I know it's a pi over 6 reference angle, and so it's sine over cosine. You can see the 2's are going to cancel out. And so it's pretty easy to get to here, but using the chart, you have that extra step of, I've got to really think about where we are. And so you would say, that's where you say, okay, 11 pi over 6, I would change pi to 6 pi over 6, and I would change 2 pi to 12 pi over 6. And so that's how I would know 11 pi over 6 is right before 12 pi over 6. It's in the fourth quadrant, and I know tangent is negative there. And so you're doing the same thing. Whether you're using the circle or the chart, you're doing the same thing. A lot of people would rather use the circle And it is easier if you have it, but the problem is you might not have it. In that case, if I don't have it, I'm using the chart. Domains of circular functions. Okay, domains, you know, a lot of people will say domain is the x number. That's not going to make sense a lot of the time, especially in trig, because we might not have an x or a y. We might have a theta. Okay, so you can think of domain as the input value, what I'm allowed to plug in. Okay, so let's think about the unit circle for a second. Okay, and all right, with my ratios, I know sine is the y and cosine is the x, and I'm talking about the unit circle, so that means r is 1. So if you put over r over 1, whatever, sine is y and cosine is x for the unit circle. And basically, if you look at all these numbers, all these x and y numbers around here, you don't have any problem. Domain questions, when they ask you about the domain, they're usually asking you where are the problems or where are there not problems. And problems generally arise when you've got a 0 on the bottom of a fraction or a square root of a negative number. That's where problems arise, problems with the domain. Okay? We don't have any problems with sine or cosine, and so we would say that the domain for either one of those two is all real numbers. Anything. The input, you can plug in anything you want. All right, but that's not going to be the case with tangent and the rest of them. Okay, look at the fractions. For tangent, we know tangent is y over x, and we know secant is 1 over x. That's in the unit circle, of course. Cotangent is x over y. Cosecant is 1 over y in the unit circle. And so what happens here, for tangent and secant anyway, if you've got x equals 0, that's going to be a problem. Okay, that's going to be a problem if you have x equals 0, because it's going to be 0 on the bottom of a fraction. That's going to mess up your domain and give you domain issues. Okay, so look at the unit circle. Look at where x equals 0. X equals 0 in those two spots. Okay, now we're in the radian chapter, so don't say 90 and 270. Say pi over 2 and 3 pi over 2. That's going to give us a problem because that's going to give us 0 on the bottom. And so the domain for those two functions, let me get this unit circle kind of out of the way. The domain for those two functions looks something like this. Theta such that theta is not equal to, okay, get a load of this, 2n plus 1 times pi over 2. Okay, now all that means is 2n plus 1, you've probably seen before. 2n plus 1 is an odd number. Okay, so this is an odd number generator. It's trying to generate an odd multiple of pi over 2, like 1 pi over 2, or 3 pi over 2, which we've seen in the unit circle, or 5 pi over 2, or 7 pi over 2, and so on and so on and so on. It's generating odd multiples of pi over 2 because we're going to get to here, and then to here, and then if we go around again, we're back here at, that would be 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, 13 pi over 2, 15 pi over 2. If we just keep going around and around and around and around and around, okay? And it all goes back to what's going to give me 0 on the bottom of a fraction. If you look at cotangent and secant, you're going to have a problem if y equals 0. And so if you look back at the unit circle, you're going to have an issue when y equals 0 right there. At 0 and at pi and at 2 pi and 3 pi, 4 pi, 5 pi, 6 pi, basically multiples of pi. So the domain for these two functions is going to look something like this. Any angle such that that angle is not equal to a multiple of pi. Like pi, 2 pi, 3 pi, 4 pi, and so on. Example 1, find the exact values of these trig functions. Okay, we've already done these. You should be comfortable with these using the chart, but check it out what happens if you use the circle. Okay, I'm going to shrink this down. If I look at the circle here, It's even easier because what you have to do is go to 3 pi over 2. That's my angle I'm looking at. And if you're finding sine, you know sine is the y coordinate. So sine 3 pi over 2 would equal that y coordinate, -1. And if I did cosine of 3 pi over 2, I'm looking at the x coordinate. So cosine 3 pi over 2 is 0. And then tangent at 3 pi over 2, we know tangent is y over x. So if you did the y coordinate over the x coordinate, you get a 0 on bottom. That's going to be undefined. It's really easy to do these problems using the chart. Using the circle. Okay? You should be comfortable also using the chart, though. So, think about what we did using the chart. If you wanted to find sine 3 pi over 2, you would first say, okay, well, I know it's a pi over 2. So if I do sine of that, it's going to be a 1. You just have to think about if it's negative or not. And so you're going to need to visualize where we're looking, okay? 3 pi over 2 is down there at the bottom, and so I know sine is negative there, hence it's -1. Cosine 3 pi over 2. So you'd say, okay, cosine pi over 2 is 0. Doesn't matter if it's positive or negative. There's no positive or negative. It's just 0. And then tangent, you're going to divide these. Okay? We got a -1 divided by 0. You're going to get undefined. So we can use the chart. We can use a circle. Both of them work. Both of them cover the same exact types of problems. Okay? So let's look at the next problem. Get this out of there. Okay. Use the unit circle to find the exact values of cosine 7 pi over 4. So we can see 7 pi over 4 down here, right? So cosine is the x coordinate. X coordinate is square root of 2 over 2. We don't really have to think about whether it's positive or negative. It just tells us right there. And sine 7 pi over 4 is the y coordinate, negative square root of 2 over 2. Find the exact value of tangent, -5 pi over 3. Here's the problem where I don't really like using the circle. Okay, because it's kind of hard to tell where -5 pi over 3 is, but you'd have to know that -5 pi over 3 goes back to here. Remember what we did? We said, all right, so pi, and this is, let's call this 3 pi over 3, and all the way around is 2 pi, so I'm going to call it 6 pi over 3. And so I guess you can still do the same way as what we did on the chart. -5 goes backwards, and it's almost around to -6. So we know we're in the first quadrant, and we know that's going to be positive, all right? But tangent, you still have to remember, is y over x. And so we're looking at these two numbers, these y numbers. There's the y number, there's the x number. When you divide those, the 2's are going to knock out, and you get the square root of 3. But remember, we're in the first quadrant, and we know all of the trig functions are positive there. So that's why that answer is positive square root of 3. I prefer using the chart. Some do, some don't. If I was going to do that problem using the chart, I know it's a pi over 3 because I can see it in the problem. I know it's a tangent, so I'm going to divide these two, and I can get the square root of 3 pretty quickly. You just have to place it, okay? And so you place it in the same way. -5 pi over 3 is going to put us in the first quadrant, so I know my result is positive. To C, find the exact value of cosine 2 pi over 3. So using the circle, it's easy. Find 2 pi over 3. And cosine is the x coordinate, so that's -1/2. If you were going to use the chart, you would know it's a pi over 3, you would know it's a cosine, so there's your 1/2, but you would just have to figure out where it is. Okay, it's always what and where. So if this is pi, We can call it 3 pi over 3. 2 pi over 3 gets us into the second quadrant. I know cosine is negative there. We get negative 1/2. Either way, be able to use the chart, be able to use the circle. They're both covering the same types of problems. Example 3, find a calculator approximation for each circular function value. Cosine 1.85. Well, this is just a calculated question. Just make sure that you are in radians. Cosine 1.85 is negative 0.2756. Okay, very straightforward. But I bet you don't know what that number represents. Okay? Let's think about what that number represents before we move on. Okay. So you should know that 1.52 is about 1.57. Okay? So if I drew an angle of 1.57, okay, that right there would be an angle of pi over 2. All right, we think of that as 90 degrees, but I'm looking at that blue angle that intercepts that red arc, and that's equal to 1.57, especially when we're talking about a unicircle. Okay? Now, I don't know where 1.85 is. Okay? So let's think about 2 pi over 3 for a second. Okay? 2 pi over 3. 2 pi over 3 is 2.09. Okay, so if 2 pi over 3 is 2.09, then 1.85 should stop short of that. 1.85 is going to take us to, I don't know, right about there, I'm guessing, ish. So let's knock out this angle. We've got some kind of angle right here. That is an angle of 1.85. Okay, that is an angle of 1.85. Now, that angle, the blue angle, intersects the red arc at this point right here. Okay, and you should be able to tell me the coordinates of that point. Well, maybe not both of them, but you should be able to tell me the x coordinate. The x coordinate of that point is negative 0.2756. How would I find the y coordinate? Shouldn't we just be able to do sine of 1.85? That number right there would indicate the y coordinate of that point. Okay, so that number that I just found, negative 0.2756, is the x coordinate of a point on the unicircle. That's what we're looking at. Okay, next one. Very straightforward. Type it in, cosine 0.5149. That's another x coordinate, 0.8703. That's the x coordinate that coincides with that angle. Anybody know what quadrant we're in? You're in quadrant 1. How'd you know that? Oh. You said 4, well, you were wrong. If you know 1.57 is pi over 2, and think about it, we didn't make it that far. 0.5149 is less than 1.57, so we only got around that far. We're looking at an angle like this, and so we just found the x coordinate of that point in that first quadrant. Okay, need to move on. Cotangent. You do not have a cotangent button, but you can do 1 over tangent. .2552. And that number is a little harder to interpret, okay? I don't know, I can't really say it's the x coordinate or the y coordinate, because remember, cotangent is the ratio of x over y. So that number is the ratio of the x coordinate to the y coordinate. Secant, we know is 1 over cosine. So we type that in. Negative 1.0243. right, now, before we move on to the next slide, I want to take you back. You already know how to do a problem like this, okay? You were kind of good at it last chapter, I think. You would have probably used the chart and said, okay, we're going to look at a cosine and a 1/2, and that pointed us at a 60-degree reference angle. Okay, cosine and 1/2. Okay, it's like an inverse cosine. But in this case, it's a 60-degree reference where cosine is negative. And so we looked at our quadrants, and we said cosine is negative over here. We've got a 60-degree reference over here. And from 0 to here, remember this is 180. 60 before 180 was 120. And 60 after 180 was 240. Those would have been our answers. You should already know how to do this. I'm getting ready to do some more complicated sort of calculator questions. All right, now, what about the unicircle? Let's say you're using the circle, not the chart. It's really kind of the same thing, okay? Kind of the same thing, but you'd have to say, well, here's a 60. You know, here's a 60 negative, or here's a 60 negative. You could do that, okay? Or wouldn't it just be easier to say the x-coordinate is negative 1/2? So here are the places where I've got an x-coordinate of negative 1/2. That would be 120 and 240. So using the circle is really, really powerful. All right? Now, something's going to change, and it's going to throw people off. They're going to give you a problem, and they're going to change it from 0 to 360 to something like 180 to 270. And so maybe they don't want the whole circle. Maybe they don't care about most of it. Maybe they only care about this quadrant right here. From 180 to 270, then the answer would only be 240. So you have to really pay attention to this interval. Some people will skip that and won't even look at it, and you're going to mess up. So we go to example 4a, and we're solving an equation, and you're supposed to pay attention to this interval right here, because that tells you where the answer is going to be. Solving this equation, you're going to have to do an inverse cosine. All I'm doing is trying to isolate. You're going to isolate the variable by undoing the operations. You're doing an inverse cosine in this problem. So S is going to equal inverse cosine of 0.9685. That's a pretty straightforward calculator computation. Make sure you're in radians. Do an inverse cosine, 0.9685. And we get 0.2517. Now, that may or may not be your answer depending on where we're supposed to look. Okay? If this interval said from 0 to 2 pi, we would have a lot more stuff going on. You'd have to say, okay, from 0 all the way around, I would look at where cosine was positive, and cosine would be positive here and here. And so you'd have to put a 0.2517 here and here and figure out what those two angles are. Well, the first quadrant answer is 0.2517. And in this case, since that's all they want to do is go from 0 to pi over 2. They only want the first quadrant answer. That means this is the only answer, and we're finished. Okay, but I want to show you what would happen if they wanted from 0 to 2 pi. You know, go back to when we were in degrees. If you wanted from 0 to 360, okay? If I was in the fourth quadrant, you would take 360. You would take 360 minus 60 or whatever it is. In this problem, 360 is equivalent to 2 pi, and so if I wanted to go all the way around, instead of saying 360 minus, you'd say 2 pi minus. And you'd get that. And that should make sense, 6.03, because 2 pi is about 6.28, okay? So 6.03 is not quite all the way around, all right? Now, all that being said, we didn't have to do any of that because we only wanted the interval between 0 and pi over 2, which only put us in the first quadrant. So that's our only answer to this. 4b, Find the exact value. When they say exact value, that's a code for you're using the chart or you're using the circle. You put your calculator down when they say exact because they don't want it. Okay, so let's look at the chart. If I look at the chart at this equation, I want to find the angle that's going to produce a tangent ratio of 1. So you should be conditioned now to know that sine over cosine, that's going to give me 1. Now don't say 45 degrees. Even though that's the right angle, the correct angle, that's the wrong language. We have to be speaking radian language with pi's and stuff, so we need to be pi over 4. That's going to be a pi over 4 reference angle where tangent is positive. And so normally what we do here is we look at where tangent is positive. Tangent is positive in the first and the third. So you'd have a pi over 4 and a pi over 4. Okay? But they only want us to look at this interval from pi to 3 pi over 2. They only want us to look at the third quadrant. That's what they're saying. And so you have to figure out what that angle is from here to here. And so you do kind of the same thing every time. Halfway around, like 180 degrees, is pi. So get a common denominator. I'll call that 4 pi over 4. We just need to go pi over 4 past that. So what's pi over 4 past 4 pi over 4? 5 pi over 4. Very good. That would be your answer.